Okay, I want to work through some examples of how to do proofs using the 4 new implication rules of predicate logic. Now, these 4 new implication rules, these 4 new rules build upon the rules that you already learned in Chapter 8, the implication rules and the replacement rules. So you want to keep all of those rules handy in your toolkit. You're just adding these. Let me review them briefly, how these rules work. So first of all, we've got universal instantiation. And universal instantiation starts with a premise like this that says for all x, x is s. And then it says that you can conclude either to this statement function, sy, or to this statement function which involves a constant, SA. Now, what's the difference between variables like x, y, z and constants like a through w? Well, variables can stand for anything. They don't pick out any particular individual. Whereas constants do. They pick out a particular individual. It's like this could be a name, you know, or it could be the dog. My dog is S. But A stands for a particular thing. Okay, so universal instantiation takes you from this universal statement to statement functions that look like this. Universal generalization goes in the opposite direction. It starts with a statement function like sy, and it concludes, therefore, for all x, x is s. Existential instantiation takes you from an existential statement to a statement function with a constant. So it says, there exists some x such that x is s. And the conclusion, you conclude then to a statement function that a is s, where a can be A can be pulled from, it doesn't have to have appeared in a previous premise. In fact, it can't be a name that has appeared in a previous line of the proof, and it can't be a name that appears in the conclusion that you're trying to derive. Existential generalization starts with a statement function that involves either a variable like sy or a constant like sa, and it concludes to an existential statement. There exists some x such that x is s. Okay, so those are our 4 new rules. And now I want to work through a proof, okay? Now, our same basic strategies that we learned in Chapter 8 are also going to apply here in Chapter 9, and that is we want to start with the conclusion that we're trying to get to, and then we're going to ask ourselves which rule and which premises will get me there. So I'm going to go ahead and paste my conclusion down here, all right? And it says for all x, if x is s, then x is not u. Now, as I look at this, here's the question I'm asking myself. Which of my rules that I've just learned is going to give me a conclusion that looks like this? Which of the rules that I've just learned is going to give me a conclusion that has this this kind of universal statement form to it? Check them out. Here's my 4 rules. Look, it's universal generalization. That will get me that kind of statement. So that's the rule I'm going to try to use. All right. Now, if I want to use universal generalization, which premise am I going to need? Well, I'm going to need a premise that looks like this. It's going to be a statement function that says, you know, for any old y, y is s. Actually, statement functions don't actually say anything. They're just patterns of statements. Because they're not bound variables, there's no quantifier, they don't actually say something. So, but in any case, here's what we're going to want. We're going to want the equivalent to sy. In our case, it's going to be this. Except instead of x's in there, we want y's. Okay. If I can get this line, then through universal generalization, I can get my conclusion. Now here's my next question. how am I going to get this premise right here? Well, at this point, I want to look back at my premises and think to myself, well, I'm going to see, do I see my premises like contained in some way, or my conclusion contained in some way in these premises? Look back at it for a second. Look at our premises. Premise 1 says, for all x, if x is s, then x is t. Premise 2 says, for all x, if x is t, then x is not u. Now, what does it look like you ought to be able to do here with these two premises? Well, it looks like you ought to be able to use hypothetical syllogism, right? And get, you know, if something is, what these two things together implies that if something is S, then it's not U. And which is pretty much what we've got here. That's what we're going for, right? Except we don't have any rules that'll get us directly. We can't apply, these two premises won't get me directly to here. What I'm going to have to do is I'm going to have to like get these statement functions out of the quantifiers and then employ hypothetical syllogism in order to get this right here. So watch this. Here's what we're going to do. We're going to use hypothetical syllogism. We know that that's what we want in order to get this. Now, what are the two premises which I'm going to need in order to use hypothetical syllogism? Here, watch. First of all, these have got to be changed to y's. Now, if I could get these two premises, then these together are going to justify use of hypothetical syllogism, which will give me this conclusion. All right, so now here's my next question. What rule can I use that will give me these premises? Well, again, let's think about our rules. Here, what we need is a rule that will take us from from a universal statement to a statement form like this. And in fact, we've got such rules, right? It's universal instantiation. This takes me from claims like for all x, x is s, to statement forms like sy. That's exactly what I need. So I'm just all I need to do here is two employments of universal instantiation on premise 1 and then on premise 2. Now I'm good to go. Now I'm just going to go back and fill in my lines. And that's going to be 3 and 4. That's going to be 5. And that's how we do it. Now, really, I just did the exact same process that I was doing in Chapter 8, right? I'm working backwards. I'm thinking which rule will get me to this conclusion. I'm looking to try to find some of, parts of the stuff I need contained in these premises. You got to know your rules, and you work backwards from the conclusions of the rules to the premises that you need to deploy them. The only difference is now you've got 4 more rules to learn, and you got to figure out, and you got to learn how they work. Hope that's helpful.